So, welcome on. Yeah, as you see, I'm going to be talking about system dynamics, mostly giving an overview, some new features as well, and introducing a quite cool feature we're going to have in a new tool, Adams Model. So just to give you an idea of what's going on in the general CUE. So yeah. Like I said, mostly discussing the system dynamics and Romex as well. Romex is quite a new tool and it's quite specialistic, so I just kind of want to get across like what it is, what you can do with it, and more importantly discuss about the synergy between Romex and Adams because it has quite some cool bridges we are building with it. And then finally, Modeler as well. So, the system dynamics CUE has really two main products, with one which is still in use but is added to it. Adams, this is a tool that has been with the brand for years now. I think somewhere in the 90s it got added, and most of our users are also familiar with it. We've got a new tool, Romex, which is specifically a design tool which is used for gearbox design, gearbox optimizations. This can both be something like cars, but also, for example, helicopters with their gearbox systems. And yeah, so I will be diving a bit further into that. Romex is really a tool designed to basically cover all the aspects we've got for a design in a gearbox. This means NVH, this is like gearbox ratios, gearbox optimization, microgeometry optimization. And more importantly, the idea is that the entire suite for Romex is integrated into one. So what you get with that is a lot of easy transportation of modules, you can do a lot of exploration of data, and you can really fine-tune your design. So just a few examples, just to get familiar with it. On the bottom left, we, for example, have a EMAG. So this is an electronic engine, or an EV. And we have this coupled together with a gearbox design. So, for example, familiar what you have on the back axle of a Tesla Model 3, for example. And we can simulate those things within Romex to get an idea of the excitations, the noise you get from it. You get an overview of where the forces are. And more importantly, you can also do a lot of durability analysis with it. So you can get a good idea of what's going on with the gearbox. So the different products we've got now currently is D6. Romex concept is an early design phase. It uses quite low fidelity simulations, and that's by design because with that you can easily run 400, 500 simulations in the span of just a minute. And you can start really working, as the name implies, on the concept design for your general layout of your gearbox. So that's like our entry-level tool, which we either use for like a very own design stage or also for sales engineers, for example, to get a lot of data out to the customer. The following tools are a lot more in-depth, so we've got Evolve, Enduro, and Spectrum. And these are different phases for the engineer to use. Enduro is really the primary one that's used for the structural simulations, for optimization, and also just getting a general idea of what how it's going to perform, how it's going to work. And also, more importantly, get the microgeometry correct, because if that's not correct, you're going to get a lot of excitations from the noise from your gearbox. Evolve is actually one of the newer additions. This is added a few years back and is mostly focused on the growing trend for EV. So the Teslas, for example, is very much up and coming, and this was focused for solutions like that. So you can get your EV into, or you get the electric motor into your gearbox design. Spectrum is the NVH tool. This is mostly focused on an NVH is noise vibration hardness. So it's mostly looking at the sound excitations that come from the gearbox, what the causes for them are, and also how you can mitigate this. So those are the three main tools. Then we also have two side tools that can be used in conjunction with the others to really get an idea of how certain module levels perform. We've got spin and energy. Spin is primarily focused on bearings, and this is really a niche tool which is used because bearings can produce a lot of sound and vibrations as well. So it's a good tool we have used for that a lot. Energy is, again, specifically focused on, together with Evolve, to really dive into how you can fine-tune electrical motors. So this is a component level tool. The others are mostly a system level tool. But with energy we can specifically start designing the EV motor or the electric motor for the use we have in the car. So that's Romex, but how does that then translate onto the bigger picture with atoms included? And the key is really in the first line. Romex is a very fast tool because it uses steady-state analysis. In other words, it's in the frequency domain. And most of the design you do within the gearbox is within this range. Just to give an idea, a car is running at a certain RPM from the engine, which is translated through the gearbox onto the wheels, and that by itself is already steady-state analysis, because if you run this run at 100 kilometers an hour, you know how the gearbox is going to run, because you have the gear ratios, you have the output ratios, and then you can calculate the frequency-based analysis of that. So this is fine for like 90% of your issues, but once you get onto the critical load cases, you have a lot of like time-independent problems. For example, when you get a point load on it and you want to see the dampening effects of a car running out in the simulation. So with that, there is an effort into really building a bridge between the two. So like I see, we have steady state and transient, and the idea is also that Atoms is not specifically designed for something, it's a sandbox. While Romex is specifically built for gearbox design. So what the idea is now is, well, can we let these two talk to each other? Is there some way we can connect Romex to Atoms? Well, luckily there is. Romex to Atoms is the newest addition that we is being developed at the CUE. It's called R2A for abbreviations, because we engineers like abbreviations, and it's really the goal for this is to get your design from Romex, so in the top right, and then get it into a Atoms environment. And the idea for that is quite simple, because doing such a design that you can do in a few minutes with the Romex is not something you can do in a few minutes in Atoms. It's just not possible. So the idea for this is to build a bridge, which we can somehow import the data from Romex, and this includes both geometry, but also the loading, the ratios, the gear properties, etc. And then run those simulations within in an Atoms time dimension. And the first effort we have currently for this is just geometry. What you see on the top right is then directly exported down into Atoms, and within Atoms we can then assign properties using Atoms machinery. And by that we can see the transient effects that are inherently not simulated within Romex. So as you see here, this is just a quick little video of this working. It's just exporting models and importing it. And for, as I said before, currently it's really, it's only geometry and some properties we can include. Further on down the line we can include FE models as well. And it's going to use settings we found in Atoms machinery, so think bearing, the change, for example, and with that we can export and run models quite fast between the two. Just another thing to mention as well, because currently it's still not available through MC1, but for the customers that do have it, later on this year it's going to be released for MC1 as well, so you have all access to it. And then you can explore your, for example, if you have such a problem, you can run it in MC1. Yeah, so that was Romex. One cool thing we're also introducing is Atoms Modeler. This is a new Apex-based environment for Atoms. We used to have Atoms View before this, and as the users of it right now, it's very powerful, but the interface is quite old, quite dated. And this is really the Atoms step into the 21st century, as I would like to say it. We'll have a lot of features, and we can make cool animations, as you see over there. It's based on the Apex platform, so the users that are familiar with the preprocessor and how to FEM or how to model with it can use this for as well. Now it's still being developed every day. New features are being added. So what they've done is they added a View switch to it, which is, as you see in the middle, you can run things in the new Apex environment, but we can also run it directly into View. And the reason for that is that some features are not built in yet for Atoms Modeler. So what you sometimes have to do is switch back to the old one and then change things to run it again in Modeler. So then what makes this such a new tool? And one of the biggest things already is that we can use the Apex features we already have, so defeaturing, meshing, and also just quite frankly creating the geometry and editing it, but then integrate it with Atoms. Because if we were to do something as shown in the video there, within Atoms View, we would have to define variables, we have to define the overall physics behind it. And if you were to move the CAD geometry in Vue, it would not move along with it because we didn't tell it to do so. But this is now automatically done within Modeler. And this sounds like such a quality of life feature, but it's up of time. The other thing is also the time management aspect of this, because it was not a CAD-based interface before Adams, and now it is. So what we can do with it is we can add way bigger CAD files to it, and we can iterate quicker on the design as well, because you just change something in CAD, import it, let it run, and get your results. So with this, we can really improve the modeling time, but also the visualization aspect of it. And the learning curve is also greatly reduced because this is much more familiar for the technology of nowadays. And LMSU is much more language-based, so much more coding. Just some cool things to see as well is we can also chart within real time. And this is really because the prediction of the analysis engine for Vue before this could not real time do this both. And we can now do it within Adams modeling. So yeah, some things to mention is that it's still very much in development. It's pushed out and everybody can download it. And actually spoke with the developer for this last week, and there are a lot of exciting things in the future, including integration with Adams machinery, native meshing using the Apex engine, and a lot of just integration of things we are familiar with in Adams Vue, but then into much more modern environment. So yeah, that's it for me. Thank you.